This next lesson is about evaluating trig ratios for what's called special angles. These special angles are very common angles, and because of that, we like to be able to get their exact values, and so that's what we're going to be focusing on. First thing I would like you to do is just circle the 3 angles in the list that you think would be the most common in everyday life. Now the ones that we're going to circle are 45 degrees, 30 degrees, and 60 degrees. And those are the special triangles that we're going to be focusing on. So what we're going to do is label these triangles, and then we're going to continue to refer to them throughout this unit with the sides that are given to them. They're based on the angles that they are. So in this triangle here, we will be calling this the 60-30 triangle. And we will have ratios associated with this. And then over here, the 45-degree triangle, which, with this right angle being 90, that makes this an isosceles triangle because 45 plus 45 is 90. So it turns out that the sides are equal. What they have done with these triangles is focus on some very fundamental numbers. So this side is 1. The side that's the hypotenuse is 2. And then the side opposite the 60, which is in between the 1 and the 2 in size, is the root of 3. And I call this the 1, 2, 3 triangle. And this other triangle, both of the sides that are equal are each 1. And then that makes this side the square root of 2 if you were to use Pythagorean's theorem. So what we're going to be doing is memorizing these triangles so that we could draw them quickly and refer to them when we're coming up with exact values using these 3 angles, 30, 45, and 60. Now just a reminder here that when you look at this triangle, the 30 is the smallest angle, so it would be opposite the smallest number, which is 1. The 2 is the hypotenuse because it's the largest number and it's opposite the right angle. And then the root 3 is in between the values of 1 and 2, so it's across from the 60, which is in between the 30 and the 90. In this triangle, because these are both the same, we have the 1 on either side here, across from the 45, and then the square root 2, which again is the largest number of the 3, and that makes it the hypotenuse. What I would like you to do in the space provided below is to write out the trig ratios for both of these triangles using sine, cos, and tan, and the reciprocals, cosecant, secant, and cotan. Starting with the first triangle, I'm going to start with the sine of 30. Remember that this is the opposite, the adjacent, and the hypotenuse. So sine of 30 is 1 over 2. The cos of 30 is root 3 over 2. And the tan of 30, which is the opposite over the adjacent, is 1 over root 3. I'm going to write SOHCAHTOA up here for us to refer to from now on. Now we need to write the 3 reciprocal ratios. So the cosecant of 30 would be the reciprocal of sine, so it's 2 over 1, or 2. The secant of 30 is the reciprocal of cos, it is 2 over the root of 3. And finally, the cotan of 30 is the reciprocal of 10, so that's root 3 over 1, or simply root 3. So there's our ratios for 30. Now coming to 60. If we're relative to the 60, that makes this the opposite. This side becomes the adjacent, and this side here is still the hypotenuse. So the sine of 60 is equal to the opposite over the hypotenuse, which is root 3 over 2. And notice because the sides switch places between the opposite and the adjacent, that these ratios are switching places. So sine 60 is root 3 over 2. The cos of 30 is root 3 over 2. The cos of 60 is the adjacent over the hypotenuse, which is 1 over 2, or 1/2. And the tan of 60 is the opposite over the adjacent, which is root 3 over 1. So that is root 3. The reciprocal functions, cosec of 60 degrees is equal to 2 over root 3, the reciprocal of sine. Secant of 60 degrees is equal to 2, reciprocal of cos, and the cotan of 60 is the reciprocal of root 3 over 1, which is 1 over root 3. Finally, looking at the 45s, the sine of 45 degrees, doesn't matter which 45 we use, I'll use this one in this corner as a reference, this one right here, opposite, the adjacent, and the hypotenuse. Sine of 45 is equal to the opposite over the hypotenuse, which is 1 over root 2. The cos of 45, because the sides are equal, is also 1 over root 2. The tan of 45 is the opposite over the adjacent, which is 1 over 1, so that's 1. The cosec of 45 is the reciprocal of 1 over root 2, so it's root 2. Similarly, the secant of 45 would be the root of 2. And the cotan of 45 is still 1, because 1 over 1 either way is 1. So those are special angles. You don't need to calculate the angles as I ended up giving them to you up here, so there is no need to do this part. Now what we're going to do is focus on something called rationalizing the denominators. When we have fractions, the whole definition of a fraction is a part of a whole. And so a math convention is not to have a number in the denominator that is not a whole number. So if you look in these cases, because we have square roots, if we calculate those on the calculator, those are decimal values. So what we want to do is come up with an equivalent fraction, ideally the simplest or lowest equivalent fraction that doesn't have a decimal or a square root or a root in the denominator. The way we can do that is simply use the property of multiplying a root by itself, because that basically gets rid of the root. So root 2 times root 2 would be 2, but we need to do the same in the numerator in order to get an equivalent fraction. So what we have is 3 root 2 over 2. In this next one, we would multiply the numerator and the denominator by root of 6. That gives us 5 root 18 all over 6. Now this 18 can be broken down to a perfect square of 9 times 2. So we need to continue simplifying that. The square root of 9 times 2 all over 6, that equals 5. The root of 9 is 3, and then the square root of 2 all over 6. Now at this point, I see canceling. I see that 3 goes into 3 once and 3 goes into 6 2 times. That leaves me with 5 root 2 over 2. Finally, for this third question, I will multiply root 7 times the denominator and the numerator. That gives me 10 root 7 all over 5 times 7. Once again, there's canceling. 10 divided by 5 is 2. I'm left with 2 root 7 over 7. So a math convention will be that anytime we have a root in our final answer that's in the denominator, we're going to do this rationalization to make sure we have a whole number in the denominator. Now the main focus of this lesson then is to take those special angles and their exact value ratios and use them to simplify trigonometric expressions and to get an exact value for them. The importance of exact values is in science applications, in engineering, etc., where you're working with formulas over and over again, or you're working with a value over and over again, and you don't want to introduce error in the very beginning. So what we do is we use exact values so that our answer will not be rounded in any way and that we don't introduce error somewhere in the beginning of some work that we're doing. So that's why we're practicing this skill. So what we're going to need here is to be able to draw the triangles and label them as a reference. So there's the 1, 2, 3. Remember that's a 60, 30. So I'm going to sketch a triangle here. 30 degrees, 60 degrees, and it's the 1, 2, 3. The 1 is the smallest side opposite the 30, the 2 is the hypotenuse, and then the root 3 is across from the 60. For the 45, it's isosceles, so it has 2 legs that are the same size, so I'll try to draw them the same. And so this should be 1 and 1. They don't look perfectly the same, but that's okay. And then this would be the square root of 2. So these are both 45s. It's okay if we just label 1. That's all we need is 1 reference angle. So what we're going to do is take these ratios and substitute their values in as exact values. So the sine of 30 is the opposite over the hypotenuse. The opposite over the hypotenuse is 1 over 2. Divided by the cos of 60. The cos of 60 is the adjacent over the hypotenuse, so that's 1 over 2. Plus the tan of 60. Tan of 60 is the opposite over the adjacent, so that is root 3 over 1, or root 3, times the tan of 30, which is the opposite over the adjacent, so that's 1 over root 3. Then what we need to do is simplify these, and we need to use our skills with radicals and fractions. Also BEDMAS, or order of operations. So 1/2 divided by 1/2, that comes first before this plus that's next. So that's 1 plus, and then root 3 times 1 over root 3. Well, this root 3, remember, has a 1 understood, and when you're multiplying fractions, you multiply the numerators and the denominators. So root 3 times 1 is root 3, and then 1 times root 3 is root 3. Now I could have canceled in this point, but I wanted to illustrate the multiplying of the fraction. So now we have 1 plus 1. So this answer simplifies to 2. Similarly, we are going to be doing this in these next questions. I'm going to draw my triangles, the 1, 2, 3, 30, 60, and then the 1 is across from the 30, the 2 is the hypotenuse, it's the largest, and square root of 3. And then I have my isosceles triangle here. So it's a 1, a 1. There's a 45 degree in here. And then root 2 is the largest side. The sine of 45 is the opposite over the hypotenuse. That's 1 over root 2. The tan of 60 is the opposite over the adjacent. So that's root 3 over 1, which is just root 3. Then we have a fraction here. The tan of 30 is the opposite over the adjacent. That's 1 over root 3. And the secant of 60, that goes with cos. So that would be the hypotenuse over the adjacent. So 60, the hypotenuse over the adjacent, that's 2 over 1, which is just 2. This fraction ends up being root 3 times 1, which is root 3, over root 2 times 1, which is root 2. There's a 1 understood under that root 3. And then we have 1 over root 3. We're going to invert and multiply. So again, think about the fact that there is a 1 understood under that 2. That's 1 over root 3 times 1 over 2. That leaves us with root 3 over root 2 plus 1 over 2 root 3. Now what we want to do is get a common denominator. So this goes back to work we've done with rational expressions. So I'm going to write my fraction here and take factors from each denominator. So I need a root of 2, I need a 2, and I need a root 3. So that's my common denominator. Looking at the first fraction, we have a root 2, we have to multiply by 2 root 3. So if I multiply the denominator by 2 root 3 to get that denominator, I also need to multiply the root 3 by 2 root 3. In the second fraction, I have a 2 root 3 already. I need to multiply by root 2. So I need to do that to the numerator. So 1 times root 2 is plus root 2. Simplifying, root 3 times root 3 is 3 times 2. So that is 6 for that first term, plus the root of 2, all over root 2 times root 3 is root 6. And then there's a 2, so we have 2 root 6. And then I'm thinking, are there any perfect squares that go in the 6? And there aren't. Now, that is the answer, except for the fact that it hasn't been rationalized. We have a root in the denominator. So we need to multiply the denominator by root 6 and do the same to the numerator. Now keep in mind that this is distribution because it's that root 6 times the whole numerator. So it's good to put brackets in here to help you remember that. Otherwise, it's not uncommon for people to make mistakes at that point. Simplifying now, what we have is root 6 times 6, which is 6 root 6, and then root 2 times root 6, so we have the root of 12, all over 2 times root 6 times root 6 is 6. You can see where these questions get more involved because there's a lot to the simplification of them. Continuing on, we have now 6 root 6. And then I know that 12 can be written as 4 times 3. And 4 is a perfect square. In the denominator, I now have 12. That leaves me with 6 root 6 plus the square root of 4 is 2 root 3. And that's all over 12. Now, once you get to this point, you need to make sure that there are no common factors that divide into all of the terms in the numerator with what's in the denominator. So what we can see is that 2 goes into 6, 2, and 12. There's 2 ways of approaching this. Simply make sure that you divide the same number into all of these. Both of these terms are being divided by 12. So in order to do the canceling, we have to cancel a number into all 3 of these. The other way of looking at it is to factor a 2 out of the numerator and then cancel it with the 12 or reduce the 2 over 12. Those are 2 approaches. So you could go ahead and factor a 2 out of the numerator using common factoring. You'll have a 2 out in front, and then you can simplify that with the 12. The other approach, which I prefer, is to simply divide 2 into all of these numbers. So 2 goes into 6 3 times. 2 goes into 2 once, so that leaves me with root 3. And 2 goes into 12 6 times. And now that's the final answer, simplified. Now at this point, this is really all you need to know in order to do these questions. I would encourage you to go ahead and try the rest of them on your own before coming back to see the solution to them. Coming back to this question here, the cos of 60 is equal to the adjacent over the hypotenuse, which is a half, minus 3 times this fraction, where we have 45s. I like the 45s because either ratio, sine or cos, or secant and cosecant, end up being the same value. So right away, I actually know that the answer to this would be 1. If you already know something like that, I would be fine with you putting a 1 in here, and that would demonstrate your understanding of these ratios. I am going to write them out. So the secant goes with cos, so it's the hypotenuse over the adjacent of 45. So the hypotenuse over the adjacent is root 2 over 1, or root 2. Now we know both of these are the same, but let's look at the cosecant, which goes with sine. So that would be the hypotenuse over the opposite. So the hypotenuse over the opposite, which is also root 2 over 1, which gives us root 2. And as you can see, root 2 over root 2 is what we said, it's 1. 2 halves is equal to 1 minus 3 times 1. And at this point, you could have simplified. I just want to make sure and show the steps. So 1 minus 3 leaves us with minus 2. And that one was a lot easier to do than the first one. Going on to the last page here, this is the consolidation. For sure, at this point, I would advise you to try these on your own before coming back to look at the answers. I'm going to start by drawing my triangles. I'm going to draw the 1, 2, 3, 30, 60, a 90. So opposite the 30 is the 1, the 2 is the hypotenuse, and the root 3 is opposite the 60. Then the isosceles triangle, 1 and 1, and then the root of 2 on the hypotenuse. And this is a 45. Coming to question 1, 2 times the sine of 30. The sine of 30 is the opposite over the hypotenuse, so that is 1/2. 3 times the cos of 60. That's the adjacent over the hypotenuse, so that is 1/2. Minus 3 times the tan of 45. Some of these you will get used to. tan of 45 is an easy one to remember, that it's just 1. If you look at the triangle, the opposite over the adjacent is 1 over 1, so that's 1. Simplifying this, I have 2 halves, which is 1, but notice that in this second fraction, it's not going to simplify. And I'm going to need a common denominator, so I might as well leave this as 2 over 2. That's where the planning comes in. So that's good evidence of planning that I would leave that rather than reduce it. So I end up with 2 over 2 plus 3 over 2. Remember, there's a 1 under that 2 in the first term, and there's a 1 under that 3 in the second term. So we multiply the numerators and multiply the denominators. And then we have a minus 3 here. This leaves us with 5 over 2. Now I'm going to make a common denominator here with that 3. So minus, if I multiply this by 2 in the denominator, I need to do the same in the numerator. And you can do that in your head, that's fine. I'm just showing the work here. So we have 5 over 2 minus 6 over 2. That leaves us with minus 1/2. Coming over to this question, 3 times the cos of 30 squared. The cos of 30 is the adjacent over the hypotenuse, which is root 3 over 2. Plus 2 times the sine of 30 squared. The sine of 30 is the opposite over the hypotenuse, which is 1 over 2. Now I'm going to square each of these numbers. So 3 times root 3 squared is going to end up being 3, because that's the definition of a root. When you multiply it by itself, you get that number. And then 2 times 2, or 2 squared, is 4. Plus 2 times 1/2 squared is 1/4. Remember, when you square a fraction, you square the numerator and square the denominator. Now what we have is 9 over 4 plus 2 over 1 times 1 over 4. So 2 times 1 is 2, 1 times 4 is 4. The answer is 11 over 4. Looking at number 3, the sine of 30 is the opposite over the hypotenuse, which is 1 over 2, plus the cos of 30, which is the adjacent over the hypotenuse, which is root 3 over 2. The sine of 60 is the opposite of 60 over the hypotenuse, which is root 3 over 2. And the cos of 45 is the opposite, and the cos of 45 is the adjacent over the hypotenuse, which is 1 over root 2. And at this point, I don't need to rationalize that because it's an intermediary step. It's not a final calculation. Now, I need a common denominator for all of these. So once again, I will take factors from each of these. So I have a 2 in the first 3. So I only need 1, 2, and then I need a root 2 from the last fraction. So the first 3 all need to be multiplied by root 2 in their numerator. So 1 times root 2 is root 2. Root 2 times root 3 is the root of 6. Root 2 times the root of 3 is the root of 6. And the root 2 needs to be multiplied by 2. So 1 times 2 is 2. Simplifying further, remember the idea of like radicals. So we have, first of all, a 2 and a plus root 2. But then we have 2 root 6s, so that's plus 2 root 6 all over 2 root 2. Now, there's different ways to approach this at this point in time. We can multiply everything by the root of 2 in the numerator and the denominator to get rid of that radical in the bottom and leave this in proper form. One thing I would like to encourage you to think about is the fact that root 2 actually goes into 2. 2 is root 2 times root 2. So if I divide root 2 into a 2, I would have the root of 2 left over. 2 divided by the root of 2 is equal to root 2. And then root 2 goes into root 2 once, and once again this root 2 will go into that 2. So let's go ahead and do that. So we're dividing root 2 into all of the terms in the numerator. So 2 divided by root 2 is the root of 2. Root 2 divided by root 2 is 1. 2 divided by root 2 is root 2, and then I have a root 6 still. That leaves me with a 2 in the denominator. Now, simplifying the numerator, I have a 1. You don't have to write the 1 first, but sometimes it's a nice way to leave it, and it's not uncommon to see that. So if I write 1, then I have the root of 2 plus root 2 times root 6, which is root 12, all over 2. Now I'm almost done, but root 12 has a perfect square that goes into it, 4. So I need to simplify that root 12. 1 plus the root of 2 plus the root of 4 times 3, all over 2. Finally, that leaves me with 1 plus the root of 2 plus the square root of 4 is 2 root 3 all over 2. And that's in its simplest form. And get used to the idea that you are going to have answers that look more complicated than what you might expect, and that this is okay. Coming to the final question here, the secant of 60, that goes with cos. So that's the hypotenuse over the adjacent. The hypotenuse over the adjacent for 60 is 2 over root 3. Something we haven't seen yet is this math convention. In the previous questions, there were brackets around the trig ratio. A math convention is, rather than having to write brackets all the time to square a trig ratio, is to put the 2 here. And that means all of the trig ratio is squared. So I need to put a squared around this 2 over root 3. Similarly for this tan of 60, that has a squared on the outside. And the tan of 60 is the opposite over the adjacent, which is root 3 over 1, or root 3. Squaring both of those, I get 4 over 3 minus 3. I need a common denominator, 4 over 3 minus, this is over 1. We need to multiply by 3 in the denominator and the numerator. That gives us 9 over 3, which makes sense. 9 divided by 3 is 3, which is what we started with, leaving us with minus 5 over 3. That's what you need to know for this topic, and you can go ahead and do the practice.